Hello learners, welcome to the third video for the lesson States of Matter. Before we move on to the contents of this video, let's have a quick recap of what we learned in the first two videos. So far in this lesson, we have learned about the definition and composition of matter. We have learned about the properties of thermal conductivity, electrical conductivity, magnetism, expansion and contraction. You've also learned about the different states of matter and the differences between the states of matter at the molecular level. About 6 phase changes in the states of matter and the examples of these phase changes. In this video, you will be learning about the types of changes that occur in nature. There are basically two classifications for changes, that is reversible and irreversible changes and physical and chemical changes. We will be looking at the differences and examples for each of these types of changes. You'll also be learning about the property of solubility of matter. You'll learn about terms called solute, solvent and solution. We'll be learning about miscible and immiscible liquids too. And you'll also be taking a close look at a scientific fact that gases also dissolve in liquids. So, are you ready for some learning? Let's get started. So, as I just mentioned, we'll be learning about two classifications of changes: reversible changes and irreversible changes, physical changes and chemical changes. Let's take a closer look at each of these. Reversible changes are changes that can be reversed or undone. If you can get back the substances you started the reaction with, then that is a reversible reaction. A reversible change might change how a material looks or feels, but it doesn't create new materials. You can find examples of reversible changes in all the phase changes. As you have seen, the arrows in the phase changes are always in both directions. This means that they are all reversible with change in temperature or pressure. Now, what are irreversible changes? A change is called irreversible if it cannot be changed back again. That is, you cannot get the material that you started out with in an irreversible change. In an irreversible change, new materials are always formed. So, if you want to identify between a reversible change and irreversible change, you have to look out for the formation or the presence of a new material. Irreversible changes are usually caused due to burning or other processes which cause permanent chemical changes. So irreversible changes almost always occur because of chemical changes, about which we are going to learn next. Physical changes and chemical changes. Physical changes are changes which happen only in the appearance of a substance. That is, the molecular composition of the substance remains the same. The kind of molecules the substance is made of does not change after the physical change. Only the form of the substance changes. This happens when the substance undergoes processes such as cutting, tearing, grinding, and mixing. For example, if you mix salt and pepper, you get a mixture of salt and pepper, but the salt would still taste salty and the pepper would still taste peppery. This is because the chemical composition or the molecular composition of the salt and pepper does not change by simply mixing them together. Do take note that not all physical changes are reversible. Some physical changes, such as when you tear a paper or when a wood is sawed into sawdust, cannot be reversed. A torn paper cannot be made whole again. Sawdust cannot be converted back into a log of wood again. Therefore, not all physical changes are reversible, but physical changes, such as phase changes, such as melting, freezing, boiling, condensing, sublimating, or depositing, are all reversible physical changes. Now, talking about chemical changes. So, chemical change results from a chemical reaction in which a new compound or product with its own properties, own distinctive properties, results as the atoms rearrange themselves to form new molecules. That is, the molecular composition changes. The atoms in the initial substance rearranges because of a chemical reaction to form new molecules. Now, not all chemical changes are irreversible either. Some chemical changes may be reversed by a different chemical reaction. There are many examples of chemical changes happening around us. For example, burning, cooking of food, rusting of metals, and rotting of organic material. Burning of substances is also known as combustion. Combustion is a process in which a substance or matter burns in the presence of air. This leads to the release of smoke, gases, heat, and light, and the end products are always products which are new and different from the original reactant. Now, talking about corrosion. Corrosion must be a new word to you. It is a chemical reaction where metals break down slowly because of other elements in their environment. And what are these other elements? They are substances such as water vapor and oxygen, which are already present in the air. So, metals such as iron, when exposed to humid air which contains water vapor as well as oxygen, they undergo a breakdown. The breakdown of metal iron is called as rusting. This process causes a product to be formed. The product formed is a crumbly orange substance, and this substance is known as rust. You must have noticed rust on top of any iron nails, iron screws, or objects which are left outside in a neglected manner. Now let's try to classify the changes which will appear as reversible changes or irreversible changes. For the sake of completion, you could also try to classify if they are physical change or chemical changes. Burning of paper is an irreversible change, and as you can see, because it is combustion, it's also a chemical change. Evaporation, condensation, and freezing, these are changes in the state of matter, and therefore they are reversible changes, and they are also physical changes. Here is an example of a metal which has undergone rusting. So this is iron which has rusted to form this crumbly orange substance which is called as rust. Therefore, rusting of iron, also known as corrosion, is an example of an irreversible chemical change. You must have noticed that when sugar is dissolved in water, the sugar disappears and you cannot make out the difference between the sugar and the water anymore. But if you heat up the water to evaporate all the water away, you will be left with the sugar particles. That means dissolving of a substance in water is a reversible process, and it is a physical change. This picture represents how milk products such as cheese and yogurt are made from milk. The process happens because of the fermentation of milk, because of bacteria present in it, and this process is a chemical reaction which is irreversible in nature. because you can never get milk back from cheese or yogurt. Tearing of paper. Tearing of paper is an example of an irreversible change because you will not be able to get the whole paper from the torn bits of paper once again. But the molecular composition of the paper does not change. The paper remains the same and is made up of the very same substance. Therefore, it is an irreversible physical change and not a chemical change in which new molecules are formed. But fruit lollies, which can be formed by freezing fruit juice, and the fruit juice that is simply formed by the melting of fruit lollies. Well, this is definitely a reversible change and it is also a physical change. What about the growing process? The process by which a living organism grows is definitely an irreversible change and the change is chemical in nature. Have you tried mixing vinegar and bicarbonate of soda? This is a kind of process that makes dough class fluffy and soft because it leads to the release of a gas called as carbon dioxide along with lots of bubbles and froth. This process is a chemical reaction and it is an irreversible reaction. Kneading of flour and baking it to form bread or cooking it to form rotis is also an example of an irreversible chemical change. Now let's learn more about the property of solubility of a substance. Solubility must be something that you are already familiar with in your daily life. Solubility is one of the properties of a substance by which its molecules separate and distribute in the space between the molecules of another substance, and all of this happens at a particular temperature. Therefore, because solubility is based on the distribution of the molecules of one substance in between the space between the molecules of another substance, it is based on the presence of space between molecules, and this is called the intermolecular space. So as you can see, solids have very little intermolecular space between them. Liquids have an intermediate amount of intermolecular space between them, which can very nicely lodge other particles or molecules. Gases have a lot of intermolecular space between them because they are not associated with each other and are freely moving around in the space available. Now let's discuss some terms related to solubility. When you mix the blue crystals of copper sulfate in water, a blue colored solution is formed. Second substance, the substance that distributes itself in the space between the molecules of another substance is called a solute. Therefore, the blue colored copper sulfate crystals are the solute in this case. The solvent that is used over here is water. So the solvent is the dissolving medium that is used to form a solution. Therefore, if you mix salt in water, salt is the solute, water is a solvent, and the solution is the salty water that you get. Let's explore the solubility of different substances in water. You could try taking these substances which are easily available in and around your homes. That is sugar, salt, sand, oil and vinegar. You can note down two types of observations. One, it looks as though none of the substance has disappeared in the solvent, that is water. It looks as if all or most of the substances has disappeared in the solvent, that is water. So the solvent in all of these. So when you try to dissolve sugar in water, you will get a very clear solution. Therefore, you would tick the second box. When you try to dissolve salt in water, once again you will get a very evenly mixed solution. Therefore, once again the second box. When you try to dissolve sand in water, it does not dissolve so evenly, and you can see the sand particles settle down. Therefore, the first box. When you try to mix oil in water, you can see that the oil separates. Therefore, it looks as though none of the substance has disappeared. Try mixing vinegar in water. You will see that you get a uniformly distributed solution. The solvent in these cases are water. The solute are sugar, salt, sand, oil and vinegar. Sugar, salt and sand are examples of solutes which are solids. Oil and vinegar are examples of solutes which are liquid in nature. Sugar is said to be soluble in water. Salt is said to be soluble in water. Sand is said to be insoluble in water. Oil is said to be insoluble in water. And vinegar is said to be soluble in water. When the solute and solvent are both liquids, there can be two cases. One is a case of water being mixed with vinegar or soy sauce or honey, wherein a evenly distributed solution is formed. Such liquids, which mix completely and entirely with each other, are known as miscible liquids. When we try to mix liquids such as oil in water, you will see that no matter how hard you try, the oil separates. This is because oil and water are immiscible liquids. This difference arises from the fact that most substances are either water loving or water hating in nature. Water loving substances would easily dissolve in water to form a solution. Water hating substances would separate from the water and will not like to mix in the water. When liquids are water hating, we get immiscible liquids. When liquids are water loving, such as vinegar, you get a proper solution. Take a close look at this figure. Guess what the numbers indicate. 6 mg per liter, 5 mg per liter, 4 mg per liter and so on up to 1 mg per liter. You can also see that the variety of life that exists in the different levels of a water body decreases as we go deeper and deeper. What do these numbers indicate? What is essential for life? Yes, it is oxygen. The numbers indicate the amount of oxygen dissolved in water. As you can see, the amount of oxygen that is available in the water will decrease as we go deeper and deeper into the water, and therefore the kind of aquatic life that exists in the deeper layers of the seas and oceans will be specially adapted and very different from what you can see in the upper layers. So this means that gases can dissolve in water, and this is very important to support life too. Can you give another example of gas dissolved in water? Yes, aerated fizzy drinks are an excellent example. You must have seen the fizz and the air that comes out when you open a bottle of Coke, because they are filled with carbon dioxide, which is another gas which is soluble in water. Now let's recap what we have learned in this video so far. We've learned about the types of changes, that is reversible and irreversible changes, physical and chemical changes. We learned that reversible changes are mostly physical changes which happen because of the change in states of matter. We also learned that irreversible changes are changes which cannot be reversed and which are mostly chemical in nature. In physical changes, there are no changes happen in molecular structure and composition of the substance. Chemical changes occur when the chemical composition of the matter changes. This happens due to chemical processes such as burning or combustion and breakdown of metals such as corrosion or rusting. We learned about the property of solubility of matter. We learned that solubility happens when solute molecules occupy the spaces between the solvent molecules. This is how a solution is formed. So water loving mixed with water to form a solution, and these are called as miscible liquids. Liquids which are water hating separate when we try to mix them with water, and they are called as immiscible liquids. That gases also dissolve in liquids. So dear students, that's all for the last video for this lesson, the states of matter. We'll see you again with a new video for the next lesson that we will be learning this year. Until then, you keep experimenting, keep learning, and keep exploring. Have fun with science. Bye bye.